Do you have tiny plastic cups that are potentially biohazardous and require washing? Well, you could do that if you use a fancy pipette, but that's if you can spare a couple $100s. But even if you do have this fancy pipette, washing these small wells is tedious because you have to rinse each one of them at least 3 times with a tiny amount of water. And honestly, who wants to do that? So, we decided to create a 3D printed system that will wash these tiny wells for you so you can spend your time doing other productive things. Our team's project is a well washing system that is being developed to be compatible with the Mobile ELIZA project. This module will eventually be incorporated into the main project's design.
There are a total of 10 3D printed pieces that make up our project. Starting from the bottom, there is a round base that fits within a square base. The round base holds a continuous servo motor. Then there is a component that fits onto the top of the servo star-shaped head that allows for the plate to be placed on top. The plate is locked into place by 2 protruding pieces that fit into the center of the plate. There are 4 poles that fit into the base. 2 of the poles are used as railings for the square plate. Finally, the top piece is placed onto the poles. The top piece has a 60-degree servo motor which is attached to a pulley that raises and lowers the plate.
Don't forget about the pumping components. We're using a small submersible aquarium pump to fill the wells and a slightly larger and stronger pump for vacuuming. Let's see those pumps in action. Now, how does it all work? Well, the motors are controlled by an Arduino Uno, which is powered by a laptop. Basically, the motors are hooked up to power, ground, and input pins. We defined each pin to the program. This allowed us to control the motors. The continuous motor on the bottom moves the plate 1 well spacing at a time. This motor only allows you to control the speed when using the Arduino. Through experimentation, we got the motor to move a specific distance by using a selected velocity and stopping it at a certain time. Then, the 60-degree motor lowers the top plate so the tip of the tubing leads to the pump sits directly in the well. This allows for filling or emptying. The water pump then fills with the appropriate amount while the vacuum pump remains on throughout the process. However, the pumps require more power than we could run through the Arduino along with our motors, so there's no video of it all working together yet. But here's what our project ended up doing.
We spent a lot of time trying to make the vertical moving part of the project work with gears, but no matter how many plates we 3D printed with minor adjustments, we couldn't get it to work. So we changed the design from gears to a pulley. We hope you liked our project, even though your tiny plastic cups are still dirty because our project isn't done. But soon we can help you with that problem.